Okay, so section 2.5, we keep going to number 6. So again, if they ask you to list all the possible answers, then you list all the possible zeros. But right now they didn't ask you to list all the possible zeros. Then we made the rate. I said I would like to guess the answer is the smallest possible answer, which is 1. So let's try if 1 is happen to be a solution or not. So okay, let me cover this one. Okay, it's better. So we use synthetic division and try to find if the remainder is 0 or not, and happen to be yes. So it means this is the quotient. Okay, so let me write down this function. If you find out 1 is not the 0, that means x minus 1 is the factor. And what's the quotient? This is 1 degree, 2 degree cube. So you have 2x cubed, take away 11x squared, plus 7x, plus 20. And no remainder. And the first factor, the 0 is 1, so first factor is x minus 1. And then we can keep going, keep x minus 1. And try to find the zeros for the quotient. So this time I guess -1 because I think you can try plug in 1, 1, 1, 1 to see if it works or not. And it looks like it doesn't work, so I try -1. And the very lucky is -1 is also one of the solutions, so x minus -1. Let me choose other color. So this is 0. So this is the quotient. And the -1 is one of the zeros. So the factor will be x minus -1. And then what's the quotient? 2x squared minus 13 plus 20. 2x squared minus 13x plus 20. So when we reduce our degree from 4th degree, so originally we have 4 degree, and we reduce to 2nd degree, it means you are able to factor by 4 for this 2nd degree. Or you may use quadratic formula to factor to find the solutions. But actually this one we are able to factor by 4. So I found the answer for you. Therefore, in the end, this function you can factor to x minus 1, x plus 1. This is x plus 1, right? And this one is this 2. 2x minus 5, x minus 4. So I found all the factors. And then I make each factor make equal 0, make equal 0. So I find all my zeros, 4 zeros here. So this is number 6. And the number 7, similar. I always want to guess. I plug in 1, looks like it doesn't work this time. And then I try and try. You can try, always use synthetic. Okay. So I only show my lucky case. But when you are trying your own luck, you may try 1, try -1, try +2, and then try 2. But first, it's better if you are not sure what's the number you need to try, then use the PQ test. Okay, the rational number test. Q is -6, P is 5. So all the possible choice may be 1 on the denominator, maybe 5 on the denominator. And the positive negative, you don't need to write down -6, just positive negative for the possible choice. Then 6, you have 1 times 6, 2 times 3, that's all, right? 1 times 6, 2 times 3. So you have all the possible choices list. And for me, I always choose 1, 2, 3, 6 first. And if not, then I will try 1 over 5. 2 over 5 is harder to choose. That's why I say be smart. We try our luck. If the easier number is going to be our answer, then we choose them first. And lucky, I choose -2, it works. So when I find out one solutions, then this quotient I can factor by for you. And I will let you try by yourself. This time is not able to be factored by for you. That's why I use quadratic formula to find the solutions. So I have one solution, two solutions, three solutions. Okay. Number 8. Try to find all the solutions. Same thing, because this leading coefficient is 1. So all you have to test is the denominator is always 1, right? And the numerator is the factor of 84. Now the factor of 84, 1 times 84, 2 times 42, 3 times 28, and keep going, many possible choice, right? But I said you don't need to choose to test every single possible zeros. I already suggest you try to guess, to test if possible answer is 1 or -1, 2 or -2, 3 or -3. You can try that. Okay. Now I try positive -1 didn't work, and I try -2 works, and find the quotient to have a remainder 0. And this quotient I want to keep going try, and this quotient I want to pay attention on 42. So 42, again, don't choose 1 and you don't need to choose positive 1. You don't need to choose positive. You don't need to choose positive 2, right? Because I chose earlier. I tried earlier, didn't work. So you may try -2, positive -3, and keep going. For 42, this time you have 42 on the numerator. So 6 times 7 is possible, one of the choice. So 42, the factor 3, 6, 7, and the positive -1, positive -2. So this time I try -6. And when you try by yourself, maybe you are not lucky enough, you try positive -1, positive -2, positive -3, didn't work or whatever. So, but you can jump to test. Okay? So when you do your own homework, will be the same number. That's why you have to practice. You practice more, then when you are on the test, you can figure out what's the right choice as fast as possible. Okay? So when I choose to test 0 is -6, and it works. So my quotient will be x squared plus 3x minus 7. This one, same thing, you need to use quadratic formula to solve for two solutions. So right now, how many solutions I have? 1, 2, 3, 4. Okay, one positive, one negative, and the -2, -6. Number 9. You list all the possible choice. Okay. So this number here, this number go to there, and then you try to find all the possible choice. 3 may factor to 1 and 3. And the 16, you have all the possible factors. And before you can sketch the graph, you need to find the x-intercept. X-intercept is y equal to 0, right? So basically, x-intercept means zeros. So how you find the zeros? Same thing, you have to guess. So I show my work. I guess 2 to have remainder 0, and I also guess 4 to have remainder 0. So you have first 0, 2, second 0, 4, and the quotient. This is a quotient. Then this quotient you make it equal 0, x equals to 2 over 3. And you make it equal 0, x equals to 4. You make it equal 0, x equals to 2. So you find 3 zeros. Number 10. Number 10 is the opposite question compared with the previous question. Previous question, I give you a polynomial, and you need to find the zeros for me. Now start from number 10. I give you 2 zeros, and ask you to give me back the polynomial. Now, pay attention here. There are many correct answers. Why? If you have a 0, 5, if you have a 0, -4i, remember last time I said you are going to have a conjugate positive 4i. So you have a positive 4i. That's not too hard. But how come we have many correct answers? Because you can choose coefficient is 1. You may choose coefficient is 4. Any number for the coefficient is okay. So therefore, you have more than one solution. You have many solutions. But normally, we just make it equal to 1. That's easier. Okay. And one more time, when you have a imaginary number or complex number for the solution, then you are going to have a conjugate for solution as well. So all you have to do is you multiply all of them together. Okay. First, you multiply these two together because 1 plus 1 minus. You can use a square minus square. And then after you simplify the second factor, then you multiply by 4 here. F O I L. F O I L. Multiply by this F times F, and the outer product, inner product, and this last times last. Okay. Number 11. Number 11, basically, they give a function and also give you one of the zero. Since they already give you one of the zero, and this is the imaginary number, so they kind of give you two zeros. 3 degree give you two zeros, so almost give you everything, right? So means this function is supposed to be f or x need to be this one times the quotient. And your job is try to find the quotient. How you find the quotient? So first you multiply these two together, and you are going to have 1 plus 1 minus. So you have, let me show you more detailed work. S squared minus 3i squared become s squared, take away 9i squared equals to s squared minus 9 times negative 1 equals to s squared plus 9. That's how I have x squared plus 9. Okay, and how you find the quotient? This is a quotient. I use long division. So f of x divided by this. After the long division, guaranteed you have 0 for the remainder. And you find the quotient. After you find the quotient, then you make this quotient equal to 0. So you solve for another 0. It will be negative, right? Negative. Number 12. Number 12 looks like we had to use rational zero test, or we say PQ test, to figure out what's our answer. So pay attention, 16 and 1. And the 16 you may have 4 as a factor, or 16 as a factor, or 1 as a factor. If I plug in 1, doesn't work. Plug in negative 1 doesn't work. You may try 2 positive negative 2. And I think you have to try by yourself. Try 1, positive negative 1, positive negative 2, and then you try positive negative 4. Here, I try negative 4 works, and use this quotient. I try negative 4 again, and we have a 0 and a new quotient. Now this new quotient, s squared plus 1, you have an imaginary solution. Okay. So when you try to find the two same zeros, so this function is x take away negative 4, x take away negative 4 again, and then quotient s squared plus 1. Okay. You have this one. Okay, so this means plus, right? And these two are the same thing, means square. Okay. So you have x plus 4 square multiplied with this quotient. And this one gives you a solution negative 4, negative 4. This one gives you a solution positive negative I. So you have 4 solutions. Now keep going to number 13. Number 13 is a little hard. Why is it hard? To me, it's very hard. Why? Because it's hard to memorize the formulas. Usually, I will teach the students how the formula came from. So you don't need to have hard time to memorize. We want to understand the formula, and we want to know how the formula came from first. But this one is just from the experience. Okay, so I can only just tell you the formula and you try to follow. So this formula, the name is the Descartes rule of sign to determine the possible number of positive and negative real zeros. We try to guess what's our zeros, or we try to guess what's our solutions. And if we have many possible choice, do we have to keep going and try and try and try, like earlier question 16 or 36, or remember earlier we have some number called 48 or 84, right? The big number. Do you want to keep going and try and try and try? Or you want to keep going and try the positive solution? Or you want to try the negative solution? Okay, so this formula give you some idea. The number of the positive real zero of the function is either equal to number of variations in sign of fx, or less than the number by an even integer. I say this formula is pretty hard. Why? Because those long sentences, how you understand, right? So how about we directly goes to the example here. Okay. So for example, this function, you have positive, negative, positive, right? So variation means the change. You change one time, change two times. Okay. So when you change two times, means how many positive answer you have. Two positive solution. Maybe, we say maybe, okay? Maybe two positive, or maybe 2 minus 2, or less than the number by an even integer. We don't want to take away 4 because it's already negative number. We are counting how many positive solutions. So when we try to decide how many positive solutions this function may have, we are talking about the real zeros. So we take a look at positive, negative, 1 change, negative, positive, 2 change. So we may have 2 positive zeros, or maybe we don't have any positive solutions. So maybe 2 or maybe 0 positive solutions. Okay. So there are either 2 or no positive. No means 0, right? No positive solutions. And how about the negative solutions? Let's keep going. The rule for the negative solution. You want to check with negative. So let's plug in negative sign to this function. H of negative x will be, let me erase so I can see later. Okay. Okay. Will be 4x squared minus 16x plus 15. Right now I want to plug in negative x. negative x. Okay, so what's our solution? Let's simplify. So you have 4x squared, because negative after square still positive. Negative is positive 16x, positive 15. Now take a look here. When you input the negative sign to the function, you want to check the negative real solutions. And how many? It will be equals to the number of the variations in sign. So let's see. Is there any variation in sign? Looks like not, right? Positive, positive, positive. No variation. No variation. Therefore, you say no negative real zeros. So that's why no negative real zeros. So this is number 13. And we have one more example, number 14. Number 14, when you want to find the positive zeros, you want to check the alternate 1 times and the normal, right? Normal alternate. So 1 positive solutions or 1 minus 2. That's negative. So there is 1 positive zeros. Okay. Now, how to check the negative answer? You plug in negative. So let's try f of negative x will be negative 4x cubed. I mental calculate. You plug in negative x. Take away 3x squared plus 2x minus 1. You plug in negative x here. You have positive. So how many negative alternate sign? 1, 2. So you have 2 negative solution or 2 minus 2 negative solution. So either 2 negative or 0 negative. So either 2 or 0 negative real. Okay. So I think you need to practice to remember these very complicated formulas. Number 15, there's another formula. So again, you know you had 2 solutions, but how big the solution is or how small the solution is. The next formula is going to tell you the boundary, or there's a bound for how high or how low, the upper bound or lower bound for the real zeros. Now let me show you the formula. I copy the formula in the end of the pages. Let me see. Okay, here. The upper bound and the lower bound rules. Probably I think it's already taken too long. Everyone is tired. So I will end the video and then come back to create a new video for keep going questions. So see you pretty soon.